Okay, so this is a video explaining solutions for the week 7's assignment. Let's get started. Okay, we will begin with question number 1. Here you are given a signal f of t, which is 2 sine squared omega naught t, and you are asked to compute the Fourier transform of this signal. Okay, so the first thing is to use the trigonometric identity. Which one we are going to use? We are going to use cos 2 theta is cos squared theta minus sine squared theta, and replacing cos squared theta by 1 minus sine squared theta, we get 1 minus 2 sine squared theta. So, from here we get 2 sine squared t is 1 minus cos 2 omega naught t. Okay. Then after this is in a form where we can use the tables. Okay. So, from the tables I know that 1 corresponds to a Fourier transform of 2 pi delta omega, and cos omega naught, cos omega c t corresponds to a Fourier transform pi delta omega minus omega c plus delta omega plus omega c. Okay. So, now we use these two things and we find that capital F of j omega is simply going to be 2 pi delta of omega minus pi delta of omega minus 2 omega naught plus delta of omega plus 2 omega naught. Okay. So, that is the answer for the Fourier transform in the first question. Okay. The second one asks you to find the Fourier transform of a Fourier series expression. Okay. F of t is a naught plus summation n equals 1 to infinity a n cos n omega naught t plus b n sin omega naught n omega naught t. Okay. This is the function in the time domain, and now we already know two of the transforms. For a constant 1, the transform is 2 pi delta of omega. For cos omega c t, the transform is pi delta omega minus omega c plus delta omega plus omega c. The only thing that is missing is sin omega c t, for which the transform is pi over j delta omega minus omega c minus delta omega plus omega c. So, now we use these three things from the table. One can directly figure out that the Fourier transform is going to be a naught times 2 pi delta of omega plus summation n equals 1 to infinity a n times pi times cos, for cos you get pi times delta omega minus n omega naught plus delta omega minus n plus n omega naught. Okay. And for the sine we have plus b n times pi over j delta omega minus n omega naught minus delta n plus delta omega plus n omega naught. Okay. So, that is the solution, and you do some simplifications. Okay. So, here you have to gather the terms for delta omega minus n omega naught and delta omega plus omega naught together and do a few basic simplifications, and you will get the answer 2 pi a naught delta of omega plus pi times, you can pull the pi common outside, summation n equals 1 to infinity. You will see that a n minus j b n multiplies delta of omega minus n omega naught, and then a n plus j b n multiplies delta omega plus n omega naught. Okay. So, that is the final answer. Okay. So, let us go to question number 3. So, here you are given an f of t which is 3 for t greater than 0 and it is minus 1 for t less than 0. Okay. So, if you want you can sketch this to see how it would look. It is minus 1 and then 3. Okay. 3 and minus 1, this is t and this is f of t. Okay. one can immediately write this in a very, in this problem can be done in so many ways. The way I am going to do it is I am going to write this f of t in terms of the unit step. You can see this can be written as 3 u of t minus u of minus t. Okay, so this part is 3 times u of t for the positive side. For this part is u of minus t, u of t flipped over and then multiplied by minus 1. So, minus u of minus t. Okay, that is the thing. So, now we need transforms for u of t and u of minus t. For u of t, the transform from the table you can find is simply 1 by j omega plus pi delta omega. Okay. What do you do for u of minus t? So, you know there is various ways to do this. So, for instance, if x of t and x of j omega are transforms, you know that I am sorry, let me write it a little bit differently. It is easy to skip the w omega j when you write this. X of t and x of omega of transforms, then you know x of a t is transforms to 1 by mod a x of omega by a, right. So, this is one of the properties of Fourier transform. So, from if you put a equals minus 1, for instance, you see that x of minus t transforms to x of minus omega. Okay. So, if I put minus t here, u of minus t would transform to, instead of omega I have to put minus omega. So, I get 1 by minus j omega plus pi delta of minus omega. But what is delta of minus omega? It is the same as delta of plus omega. Okay. So, this is the same as delta of plus omega. So, we simply get minus 1 by j omega plus pi delta of omega. So, once you know these two transforms, the transform for f of t is also very easy. It is 3 times 1 by j omega plus pi delta of omega minus 1 by j omega plus pi delta of omega. Okay. So, you simplify this, you will get the answer 2 pi delta of omega plus 4 by j omega. Okay. So, that is question number 3. So, question number 4 asks you to find the Fourier transform of a square wave. So, for that if you let f of t be the square wave that is given in the question, okay, I believe it is like this, right. It is a periodic square wave, it keeps repeating like this, it repeats like this throughout 0, t naught by 2, t naught, and I believe the amplitude is a and minus a. Okay. So, this is a square wave. The first step when you want to find Fourier transform for periodic signals is to write the Fourier series for this signal. Okay. So, you can write f of t. Usually the exponential Fourier series is quite easy to write down. You might want to write this f of t as a Fourier series of e power j n omega naught t. Okay. So, I am not going to show you how you do the Fourier series for this in detail. I believe one of the earlier assignment questions had this. You can see if you do a calculation that a naught is going to be 0 and a n is going to be 0 for n even and 2a by j n pi for n odd. Okay. This is going to be the form of the for a n, okay, the Fourier series coefficients for this periodic signal. Okay. That is the first step. So, it turns out if you use this formula, f of t can be written as a naught is 0 and a n is non-zero only for n odd. Okay. So, one can write this in this form, for instance k equals minus infinity to infinity 2a by j 2k plus 1 pi, okay, times e power j 2k plus 1 omega naught t. What is omega naught? Omega naught is 1 by t naught or 2 pi by t naught, sorry. Okay. So, you know one can write it like this, right, for every odd. So, 2k plus 1 is an odd number, right, it is odd. As k goes from minus infinity to infinity, 2k plus 1 goes over all the odd numbers. So, for every odd number you have a coefficient 2a by j 2k plus 1 pi and then e power j 2k plus 1 omega naught t. Okay. So, if you want you can replace k by n as well, so it is the same thing. Okay. So, from once you have this form, the Fourier transform is easy to find down, and this is just a question of writing it down in a straightforward way. K equals minus infinity to infinity 2a by j 2k plus 1 pi, that comes by its own, and e power j omega c t has this transform, right. So, you know this transform e power j omega c t has the transform 2 pi delta omega minus omega c, that is the transform for this. So, you can write this as 2 pi times delta omega minus 2 k plus 1 omega naught. Okay. So, this pi and pi would cancel, and you can simplify this finally to the slightly more simplified form k equals minus infinity to infinity 4 a by j 2 k plus 1 delta omega minus 2 k plus 1 omega naught. So, that is the problem. Okay. So, that is the Fourier transform for the fourth question. Let us move on to the fifth one. So, here you are given, let me just make sure I get the question right. The fifth one asks you to find a Fourier transform. Okay. So, the Fourier transform is given to you, capital F of j omega is given to be 2 pi for omega greater than or equal to 0 and 0 for omega less than 0. So, now in one way to write this is 2 pi times the unit step in omega, okay, and you have to find the time domain expression for it. The Fourier transform is given to you. Okay. So, here again one can use something known as duality. For instance, you know u of t transforms to 1 by j omega plus by delta of omega. There is a property called duality which says x of t transforms to x of omega implies capital X of t. Okay. So, when you see the Fourier transform function and instead of omega put t in it, you get that transforming to 2 pi x of minus omega. Okay. So, now if I use duality here, what will happen? This guy which is capital X should become, instead of omega I should put t there. So, 1 by j t plus by delta of t transforms to 2 pi times u of minus omega, right. So, whatever I have here 2 pi times whatever I have here, instead of t I have to put minus omega. Okay. So, now so that is the first property that I want to use, and then you have the other property which we saw before. So, if x of t is x of omega, x of minus t transforms to capital X of minus omega. So, here I have 2 pi u of minus omega, I want 2 pi omega. So, if I use the second property here, I can get 2 pi u of omega, instead of t I should put minus t here. So, 1 by minus j t plus pi delta of minus t, but once again notice delta of minus t is the same as delta of t. So, this just becomes equal to pi delta of t minus 1 by j t. Okay. So, that is the answer. The Fourier transform of 2 pi, the inverse Fourier transform of 2 pi u of omega, which is actually f of j omega, and f of t becomes equal to pi delta of t minus 1 by j t. Okay. So, that is the fifth question. Let us move on to the sixth one. Okay. The sixth one is a bit interesting. You have to use a different property. You are given a time domain signal which is sine omega naught t times u of t. Okay. So, there are two signals and you multiply. Okay. So, there is an easy property that we have once again. If x of t and y of t multiply, they Fourier transform to 1 by 2 pi times the convolution of x of omega and y of omega. Okay. So, this is a property that we will use. So, now if this is treated as x of t, sin omega naught t, we will treat it as x of t in this. We know that transforms to pi by j delta omega minus omega naught minus delta omega plus omega naught. Okay. And we know u of t transforms to 1 by j omega plus 2 pi delta of omega. So, when you take the product of these two, it transforms to the convolution. So, f of t, which is equal to sin omega naught t times u of t, transforms to 1 by 2 pi the convolution of pi by j delta omega minus omega naught minus delta omega plus omega naught convolved with 1 by j omega plus 2 pi delta of omega. Okay. So, this is the answer for this is the form of the answer. Now, we can try and simplify. Okay. So, for instance, you can cancel pi and pull the 1 over 2j outside. Okay. So you get yeah, so this is what you get. So you get 1 by 2j times, right, two expressions here, which one needs to be a little bit careful here. So let me just write it a little bit carefully. Delta of omega minus omega naught convolved with 1 by j omega plus delta of omega minus omega naught convolved with 2 pi delta of omega. Then minus delta of omega plus omega naught convolved with 1 by j omega minus delta of omega plus omega naught convolved with 2 pi delta of omega. Okay, so this is the final form of the answer. And now we know, let's look at this convolution. Okay, so anything, so any function convolved with delta is simply the same function, right, delta of omega. So that's one of the properties we know. What is the property of the delta function? Delta of omega convolved with any f of omega is the same as f of omega. Okay, so we know this property. So one uses that property first, and then what is the other property you can use? Delta of omega minus omega naught convolved with any f of omega will become f of omega minus omega naught. Okay, so these are the two properties that I am going to use here. The first property and the second property. So you can use the first property here and here. You can use the second property here and here. Okay, so if you do that, you will get 1 by 2j times, for this guy it's f of omega, whatever f of omega is, instead of omega I should put omega minus omega naught. So I get 1 by j omega minus omega naught. Okay, and then for this guy, instead of f of omega I should put omega plus omega naught. So I get minus 1 by j omega plus omega naught. Okay. Okay. And then for the other two expressions, I am going to get the same thing. So 2 pi times delta omega minus omega naught minus 2 pi times delta omega plus omega naught, because it is a convolution with this guy. Okay. So just check this. Okay, so I think 2 pi I got wrong here, I am sorry. U of t, there is no 2 here. So this factor of 2 should actually not be there, I am very sorry. Okay, so the 2 should not be there, so that 2 goes away. And then the other things I think are okay. Okay, I think the other things are okay. Alright, so now we have to just further simplify this a little bit. So if you look at the first two terms, if I multiply it with 1 by 2j, so if I take the 1 by 2j outside, let me deal with this term first. So this term is like this, I multiply by 1 by 2j, so I get pi by 2j times delta of omega minus omega naught minus delta of omega plus omega naught. Okay, that is easy to deal with. And then you have the other term for which I get plus 1 by 2j times j. Okay, the j will come out, and then I have 1 by omega minus omega naught minus, is there a minus? Yeah, minus 1 by omega plus omega naught. Okay, so now one can simplify this further. The first part you keep as it is, delta omega minus omega naught minus delta omega plus omega naught, and then you carefully simplify this. J into j is minus 1, and then you do the simplification, you will get plus omega naught plus divided by omega naught square minus omega squared. Okay, so this is just the addition of these two things, and that is the end of the 6th question. Okay, so let us move on to the 7th question. It is considerably simpler. Here you have two signals f of t which has a Fourier transform sin omega by omega. Another signal g of t which has the Fourier transform 2 times cosine omega by omega. And now you are asked to find the Fourier transform of f of t convolved with g of t. This is very easy. This is simply, if you convolve in time domain, you have to multiply in the frequency domain. So you have to take the Fourier transform of f of t and the Fourier transform of g of t and multiply it together. So you get 2 sin omega cos omega by omega squared. What is 2 sin omega cos omega? It is the same as sin 2 omega. So, you get sin 2 omega by omega squared. Okay, so, that is the 7th question. Let us move on to the 8th one. Okay, so, this is a slightly more interesting one. Okay, so, you have a relationship between g of t and f of tau. It says minus infinity to t f of tau d tau. Okay. So, it turns out this integral relationship can be written in fact as f of t convolved with u of t. The reason is, what is f of t convolved with u of t? If you look at u of t is 1 from 0 onwards, right. So, what is u of minus t? U of minus t is 1 and then it goes to 0, right. So, this is okay, let us say u of tau, this is u of tau, okay, u of tau is like this, u of minus tau is like this, right. And then what is u of t minus tau? It is simply this thing shifted right up to t. Okay, so, this is u of t minus tau. So, what is the convolution of f of t with u of t? It is integral minus infinity to infinity f of tau u of t minus tau t tau. Now, what is u of t minus tau? It is 1 from minus infinity to t, okay. And beyond t it goes to 0. So, this guy goes to 0 beyond t. So, this integral is the same as minus infinity to tau f of tau d tau. Okay. So, this formula is the same as the integral, okay, that is the first step. So, if you want to find, so g of t, okay, so if you want to find the Fourier transform of g of t, g of j omega, we know is going to be it is going to be 1 by 2 pi, no, is there a 1 by 2 pi? No, there is convolution in the time domain. So, you should get, don't you get a 1 by 2 pi? Multiplication in time domain has a 1 by 2 pi, just let me just check that formula, yeah. So, it is convolution in the time domain, so it is just multiplication in the Fourier domain. So, it is just multiplication of f of j omega times the Fourier transform of u of t, which is 1 by j omega plus pi delta of omega. Okay, it is just this product, and this can be actually simplified. You can write it as f of j omega by j omega plus pi times f of j omega times delta of omega. But what is f of j omega delta of omega? We know this formula that f of omega delta of omega is the same as f of 0 delta of omega. Okay, we know that that is true, right. So, you use that formula here, you are going to get this to be equal to f of j omega by j omega plus pi f of 0 times delta omega. Okay, so, that is the solution for the 8th question. Okay, so, let us move on to the 9th one. Okay, so, the 9th one involves two functions f of t and g of t, and both of them are square functions. So, let us first of all use this following result from the tables. Okay, so, this is an important result from the tables. Suppose you have a square signal f of t, okay, let me maybe I will call it x of t, okay, a square signal x of t which is 1 from minus t to t. We know from our tables that this transforms to 2 times sin omega t by omega. Okay, so, this is the most important result here from the tables. So, now you have f of t which is given in the problem as a signal which is half from minus 1 to 1. It is half from minus 1 to 1. This is f of t. Now, this will Fourier transform by using this formula. In this formula, we have to first multiply by half because this is 1. On the other hand, this amplitude is half. So, you have to multiply by half, and then you simply have to say that the capital T is equal to 1. Okay. So, you do that, you get sin omega by omega. So, if you want, instead of the a here, you can put a here and you will simply get a multiplication by a. Okay. So, this here you can identify a to be half and t to be 1. So, you simply get this formula. So, likewise you also have g of t. G of t is given to be 1 from minus half to half. that is 1. So, this will transform to sine, no I am sorry, here did I miss something, I missed the 2, okay, so sorry. So, here this will transform to a is 1 and t is half, right. So, a is 1 and t is half. So, this will transform to 1 times 2 sine omega times half divided by omega. So, this is 2 sine omega by 2 by omega, okay. And then you have to find the Fourier transform of f of t convolved with g of t. This we know simply is the Fourier transform of, is simply the multiplication of the Fourier transform of f of t and g of t individually, okay. This is the convolution property. So, you simply get this is sine omega by omega. So, you get sine omega by omega times 2 sine omega by 2 by omega, which simplifies to 2 sine omega by 2 by omega squared, okay. So, that is the 9th problem. So, let us move on to the 10th one. So, the 10th one gives you the relationship, I believe it says, yeah. So, it gives you g of t as integral minus infinity to t f of tau d tau. So, from a previous problem we know that you have this relationship g of j omega is f of j omega divided by j omega plus pi f of 0 delta of omega, okay. This we know to be true, okay. So, now you are asked to evaluate g of j omega at omega equal to 1. So, if you do this, you have to put omega equal to 1 here. So, you get f of j omega for omega equal to 1 divided by j into 1, omega is 1, plus pi f of 0 times what is going to be delta of omega when omega is 1, that is going to be 0, okay. So, this thing simply evaluates to f of j omega at omega equal to 1, and that is given as 2j. So, 2j divided by j, which is equal to 2, okay. So, that is the 10th question. The 11th question is actually asks you to find the output of an LTI system. So, x of t is actually a times e power j omega naught t, and this is sent as an input to an LTI system with the frequency response h of j omega, and it asks you to find the output y of t, okay. So, now it is good to deal with the Fourier transform. So, if you look at the Fourier transform, x of j omega is basically a times 2 pi delta omega minus omega naught. So, y of j omega, which is the Fourier transform of y of t, is simply x of j omega times h of j omega, because this is a LTI system, and that is a times 2 pi times delta of omega minus omega naught times h of j omega. So, now once again we know this property of f of omega times delta of omega minus omega naught is the same as f of omega naught times delta of omega minus omega naught. So, if you write this down, you simply get 2 pi a times, so this formula instead of f you use h. So, instead of omega you have to put omega naught, h of j omega naught times delta omega minus omega naught, okay. So, that is y of j omega. So, from here if you want to go back to the time domain, you quickly get that y of t is 2 pi a h of j omega naught. Remember, h of j omega naught is now a constant, it is not varying with this, and in fact the 2 pi will get absorbed into that. So, let me write this. So, 2 pi into 2 pi times delta omega minus omega naught actually becomes e power j omega naught t when you do the Fourier transform. So, the answer for y of t is simply that, and from here you can figure out what are all the choices which are correct. So, for instance, in case if you want to look at absolute value of omega y of t, it is simply going to be absolute value of a times h of j omega naught times times the absolute value of e power j omega naught t, and this guy is absolute value is equal to 1. So, this will just simplify in absolute value to just absolute value of a times the absolute value of h of j omega naught, okay. So, there is lots of simplifications that are possible, and these are the results. So, this basically tells you if a complex exponential enters an LTI system, what you get out is again a complex exponential except that the amplitude and phase are changed by the evaluation of the frequency response at omega naught. Okay, so that is the result here. Okay, so that is 11 and we are ready to go to 12. Okay, so 12, 13 and 14 actually constitute, okay, so 12 is quite easy. 12 is simply a convolution question. So, y of j omega is h of j omega times x of j omega, and anything you want will come out of it. So, the absolute values will be the product of the absolute values. The phase of y of j omega will be the sum of the phase of h of j omega and x of j omega. Okay, so that can be written down. So, now 13, 14 and 15 are a circuit solving question. So, a circuit is given with a certain input and a certain output marked, and you have to find the output for different types of input. Okay. So, let me write down the circuit and see how to work with it. The circuit has a current source Is of t, and then there is a 1 ohm resistance, and then there is a capacitance which is 1 by 3 farad, and then there is a 2 ohm resistance, and the output is marked as the the voltage across the 2 ohm resistance. Now, it is good to go to the transform picture. In the transform picture, if you do a Fourier transform version of this, you have a Is of j omega going out to a impedance which is just 1 here, and here for the capacitance the impedance is going to be 1 by j omega into C, which is 1 by 3, which is 3 by j omega, and then you have another impedance here which is again 2, okay, and then across this you are going to get V naught of j omega. So, now we have to write some simple equations. So, for instance, if you take, so I mean you can write a node equation or a loop equation. I am not going to go into too much detail here, but if you solve this circuit, how do you solve this circuit? So, maybe I should write down how to do this. So, let us say you take the I do not know, the current on this loop as some I of j omega. Okay. So, that can be done in some fashion. Then if you do that, and if you start writing loop equations, you can see what you will get. So, for instance, if you write this, then the voltage across 1 ohm resistance, the transform of the voltage is simply I of j omega times 3 by j omega plus I of j omega times 2, right. That is the voltage across the 1 ohm resistance. So, the current through, okay, so I should put this current through 1 ohm resistance will transform to the voltage itself. It will be the same as this guy, I of j omega times 3 by j omega plus 2. Okay, so, that will be the current through the 1 ohm resistance, and now we know overall that Is of j omega has to be equal to I of j omega plus I of j omega times 3 by j omega plus 2. Okay, so, the incoming current here has to be equal to the current here plus the current there, and that gives you this equation. So, now we also know, so one can find I of j omega. Okay, let me write it more reasonably here. So, the I of j omega becomes equal to so one can simplify this a little bit. Okay, so maybe I should write a few more steps here. Let me write a few more steps here. It's just simple equation solving, but nevertheless it is good to write that down. 1 plus 3 by j omega plus 3 times plus 2, I am sorry, plus 2 times I of j omega, and one can simplify this further. So, you write Is of j omega is actually 3 times 1 plus j omega by j omega into I of j omega, and one can simplify this further and write I of j omega is actually j omega by j omega plus 1 times 1 by 3 times Is of j omega. Okay. So, now I of j omega is not what I want is 2 times I of j omega, right. So, V naught of j omega is 2 times I of j omega, and that one can write as 2 by 3 times j omega by j omega plus 1 times is of j omega. Okay, so one can do this in so many other ways. I just showed you one laborious way of doing it. You can also write a node equation for the node in the middle and get it for etc. So this is the crucial relationship. What is the crucial relationship? V naught of j omega is 2 by 3 times j omega by j omega plus 1 times is of j omega. This is the main system function which is true for any is of t, and you can substitute and get your answer. Okay, so this is the crucial relationship. Once you have this relationship, each of the other problems is easy. The first problem, 13th itself, asks you to find when is of t is delta of t. Is of t delta of t transforms to is of j omega, which is simply equal to 1, right. So, this is just 1. So, if you do that, V naught of j omega, if you put is of j omega equal to 1, you simply get 2 by 3 times j omega by j omega plus 1, and that can be written as 2 by 3 times 1 minus 1 by, I am sorry, 1 by, no, 1 minus, I am sorry, that's correct, 1 minus 1 by j omega plus 1. Okay. In this form, one can easily transform this. So, if you transform, you see that you have 2 by 3. Okay. So, if you want, you can write it down, 2 by 3 minus 2 by 3 into 1 by j omega plus 1. Okay. So, 2 by 3 will simply transform to 2 by 3 times delta of t. Okay. So, this is something we know, delta of t has a Fourier transform of 1, and we also know 1 by j omega plus a has a Fourier transform of e power minus at u of t. Is that right? So, once you do this, using these two transforms, one can easily solve these problems. Okay. So, 1 by j omega plus 1, you have to put a equals 1 here. Okay. So, a is equal to 1. So, you simply get 2 by 3 times e power minus t u of t. Okay. So, that is the output, and from here you can read off the values needed in the choices given in the answer. Okay. So, that is question number 13. For 14, also you use the same relationship. The relationship between the input and output is the same, except that is of t has now become u of t, right. So, for u of t, you have the transform is of j omega being 1 by j omega plus pi delta of omega. Okay. So, if this is the input, your V naught of j omega is going to be 2 by 3 j omega by j omega plus 1 times this guy 1 by j omega plus pi delta of omega. Once again, there will be two components to this answer. One is just the first term. So, that is 2 by 3 to 1 by j omega plus 1, and the next term is 2 by 3 into j omega by j omega plus 1 times pi times delta of omega. Now, if you remember, I have this relationship that f of omega times delta of omega is equal to f of 0 times delta of omega. Okay, this is the relationship. Okay, and this plays the role of f of omega here, and what is f of 0 is actually 0, right. If you put omega equal to 0, this thing vanishes. So, if this vanishes, the f of 0 goes to 0, 0 into delta of omega becomes 0. So, this entire second term goes off to 0, and you simply get 2 by 3 1 by j omega plus 1. Okay. So, now if you do transform, if you do a transform, you get V naught of t is 2 by 3 e power minus t u of t. Okay. So, once again from here you can read out the values of a and b. Okay. The last question is 15. Here again is of t is given as a signal like this, 1 from 0 to t, this is is of t. So, once again one can find the transform of this. It is possible to also do this problem in another way, because is of t can be written as, if you want, you can do the transform. So, if you do the transform, you will get is of j omega, okay, and then from there you can proceed. So, this will actually be a shifted form of a square wave. If you want, you can use that and do it, but there is a simpler way to do this problem, and that simpler way is to simply write is of t as u of t minus u of t minus 2. If you write that, then you know the response for u of t Okay. So, the response for u of t we saw in the previous problem is simply 2 by 3 e power minus t u of t. What will be the response of u of t minus 2? This is after all a LTI system. If you give input u of t, you get a certain output. If you give an input u of t minus 2, instead of t, you have to put t minus 2. So, it just becomes minus 2 by 3 e power minus t by 2 u of t minus 2. So, that is the v naught of t. So, the question actually asks for v naught of 1. If you put t equals 1, you get 2 by 3 e power minus 1 u of 1 minus 2 by 3 e power minus e power minus of minus 1 u of minus 1. So, now u of minus 1 is equal to 0, u of 1 is equal to 1. So, this simply simplifies to 2 by 3 e power minus 1. Okay. You are also asked to find v naught of 3, which will become 2 by 3 e power minus 3 u of 3 minus 2 by 3 e power minus 1 u of 1. Both of these guys are equal to plus 1. So, this simply evaluates to 2 by 3 times e power minus 3 minus e power minus 1. Okay. So, these are all the answers, and that is the end of the solutions for week 7. Thank you very much.